Picture a sprawling, noisy 19th century textile factory. You know, hundreds of workers, belts spinning, pulleys clacking.
Right, and everything is powered by one giant steam engine down in the basement.
Exactly. Now imagine a wealthy factory owner today, right now in 2026, decides to upgrade. So they buy the most advanced, cutting-edge artificial intelligence system on the market.
Huge investment.
Right. They drag it into that factory and they try to hook it up to those old leather belts. What happened?
I mean, absolutely nothing. Or, well, worse, the whole system just violently breaks down.
Because we spend so much time obsessing over the newest technology that we completely ignore the actual architecture of the building we're trying to put it in.
Which is exactly why so many massive corporations right now are spending billions of dollars on AI and seeing zero actual return on investment. The architecture is literally rejecting the tool.
Welcome to your custom-tailored deep dive. Today, we are taking a really hard look at the hidden mechanics of productivity.
It's a fascinating topic.
It really is. We've got this stack of fresh, hard data from the latest A16's Charts of the Week newsletter, just published today, June 26, 2026. And our mission today is to cut through all the tech hype.
And there's a lot of hype.
Oh, tons. We want to decode why the current tech cycle is behaving unlike anything we've seen before. By the end of this deep dive, you'll understand why slapping an AI tool onto your current workflow might actually be a terrible strategic error.
A very expensive error, yeah.
You'll also see how single individuals are building 8-figure businesses strictly from their laptops, and why your local grocery store is basically the perfect, kind of hilarious example of technology actually slowing us down.
To really grasp this paradox of productivity we're living through, we kind of have to start by zooming way, way out.
Let's do it.
The overarching theme tying all these charts together is a violent structural rotation in the broader market since the post-pandemic era began.
Right.
I mean, the global economy is physically reorganizing itself.
Okay, let's unpack this, because looking at the charts, it's like a complete mirror image of the last decade.
It really is.
If you compare the post-financial crisis era, you know, that 2010 to 2020 stretch to our current post-pandemic cycle, technology is the only consistent winner in both.
Right. Tech always wins.
But beyond tech, everything else is violently inverted.
It is a profound inversion. Think about the absolute darlings of the 2010s. You had healthcare, consumer products, media companies.
Safe bets.
Exactly. Those sectors were reliably delivering double-digit returns year after year. Fast forward to today, and they are crawling along at a sluggish, 3 to 6%.
Wow. While the sectors everyone completely ignored for a decade, I'm talking energy, raw materials, heavy construction, financials, they've suddenly jumped from low single digits up to mid and high double-digit returns.
Right, they are soaring.
I'm looking at this data and thinking, wait, aren't we in an artificial intelligence software boom? Why are concrete and raw materials outperforming digital consumer products?
Because we are undergoing a massive seismic transition from bits to atoms.
Bits to atoms. Tell me more about that.
Well, for the last 10 to 15 years, the smartest capital out there chased asset-light software. You wrote some code, hosted it in the cloud, and you could scale infinitely with almost zero physical footprint.
It was cheap to run.
Extremely cheap. But an AI software boom demands a physical reality. You cannot run these massive large language models without sprawling data centers. And those require copper, concrete, intense cooling systems, and just gigawatts of energy.
So the digital brain we spent a decade building now requires a staggeringly heavy physical infrastructure just to house it.
Exactly. And the private market data backs that up in a shocking way, especially when you look at robotics and physical AI.
Yes, the robotics chart is wild. A decade ago in 2016, robotics didn't even crack the top 100 private company category.
It was barely a novelty back then.
Today, it is the #2 largest category in the private markets. It completely eclipsed fintech. It eclipsed digital payments.
And the velocity of that capital shift is what really stands out here. Just in the first quarter of this year, roughly $16 billion was invested across about 500 different robotics deals.
16 billion in one quarter.
Right. To put that in perspective, that Q1 total is 4.5 times larger by value than the entire stretch from 2021 through 2025 combined.
That is just an unbelievable acceleration. But help me understand the mechanism here, because software is inherently scalable, right?
Usually, yes.
But a robot has to be manufactured, shipped, maintained. Why are investors suddenly so eager to embrace all that real-world friction?
Because hardware is no longer just a rigid, dumb container for software.
Yeah.
Driven heavily by expanding global defense budgets, which act as a massive proving ground for these technologies, hardware is becoming the product itself.
Oh, interesting.
Yeah. AI has advanced to the point where it can unlock complex, real-world tasks that traditional software could never touch. Navigating a warehouse, sorting irregular materials, autonomous physical security.
Because software alone cannot pick up a physical box.
Exactly. But AI-powered hardware can.
It's like Silicon Valley spent a decade obsessed with building a massive floating digital brain, and now they're suddenly panicking to build the physical body, the hardware and robotics, so that brain can actually touch the real world.
That is the exact dynamic playing out.
Yeah.
But connecting that brain to the real world brings us to a really severe bottleneck,
Yeah.
especially for the established corporate giants.
Right, because big companies are really struggling with this.
They are. We are seeing a fascinating phenomenon that researchers are calling the illusion of AI adoption.
And this is where the data gets incredibly counterintuitive. Because in the early days of the generative AI boom, the assumption was that big legacy companies would panic, realize they needed AI, and immediately hire giant management consultancies to do all the heavy lifting.
Yep, the big agencies.
Right. Companies like Accenture were predicted to be the ultimate winners here. They provide the roadmap, they install the software, and they just collect a fortune.
That was definitely the market consensus. And for a brief moment, it actually played out that way. Accenture's free cash flow multiple, which is basically how the market measures its confidence in a company's future cash generation compared to its current valuation, climbed to around 30 times in early 2025.
30 times. So investors were pricing in a decade of guaranteed AI implementation contracts.
They were. But today, that multiple has plummeted to roughly 6 times.
The premium just completely evaporated.
Evaporated.
But why? Are the consultancies just bad at installing the software?
What's fascinating here is that it is not a failure of installation at all. It is a failure of imagination.
Okay, what does that mean?
This brings us to a really critical study of 515 high-growth startups that completely redefines how we should be looking at AI integration. The researchers identified something they call the mapping problem.
Walk me through this mapping problem, because my assumption is that if a Fortune 500 company buys top-tier AI tools, productivity should just naturally follow.
You would definitely think so. But the study divided companies into 2 camps. First, you have the standard firms. These are companies that mapped AI directly onto their legacy processes.
Okay.
They look at a multi-step workflow, say customer service routing, and said, let's keep the exact same 10-step process, but we will just use AI to do step 3 and step 7 a little bit faster.
Wait, so just buying an expensive enterprise AI tool doesn't automatically make a company more productive? Are these legacy companies essentially just using a nuclear reactor to power a horse-drawn carriage?
That is the perfect way to put it. They are just treating it like a slightly faster calculator. But the second group, which the researchers called the treatment firms, did something entirely different.
The AI native ones.
Exactly. Instead of mapping AI onto old steps, they rewired their entire business outcomes around what AI is actually capable of. They asked, given what this tech can do we even need a 10-step process at all?
Do you have a concrete example of what that rewiring actually looks like in practice? Because, rewiring architecture can sound a bit abstract.
Sure. Think about a traditional corporate legal department drafting a contract. In a standard firm, an analyst gathers the data, hands it to a junior lawyer who drafts the document, who hands it to a senior partner for review, who sends it to compliance.
A very standard assembly line.
Right. Bolting AI onto that just means the junior lawyer uses a language model to type their draft faster. The hierarchy totally remains.
Okay, so what does the treatment firm do?
An AI-native treatment firm redesigns the goal. The system automatically pulls the data, drafts the contract, runs the compliance check simultaneously, and flags only anomalous clauses for one single human reviewer. The entire assembly line is gone.
Wow. And the results from the study are undeniable. When you look at the top 5% of these startups, what the researchers call the top vigentile, the ones that actually rewire their processes, found 44% more use cases for AI.
Almost half again as many.
Yeah, and they generated twice the revenue of the standard firms.
Yeah.
But here is the truly wild part. They consumed 40% less capital to do it.
They're achieving double the output with significantly fewer resources because they actually solved the bottleneck.
Right.
The bottleneck is not the capability of the language model.
Yeah.
The bottleneck is discovering where and how to deploy it. which requires dismantling your existing corporate structures.
This circles perfectly back to that factory analogy from the intro, which I am honestly slightly obsessed with.
It's a great historical parallel.
When factories first began electrifying in the late 19th and early 20th centuries, they didn't see an immediate productivity boom. Why? Because the early adopters just ripped out their central steam engine and put a giant electric motor in the exact same spot.
Yes, and they kept the entire legacy architecture of the factory completely intact.
The belts and everything.
All those heavy overhead line shafts, the complicated leather belts stretching across the ceiling to power individual workstations, they were essentially running an electric motor to power a steam engine factory.
They didn't understand the new medium at all.
Not at all. The real transformative leap in manufacturing only happened when managers realized electricity allowed them to decentralize power.
Right.
They could scrap the overhead belts entirely, redesign the factory floor for maximum workflow efficiency, and put a tiny electric motor inside every single machine.
So the ROI wasn't in the tool itself, it was in the structural imagination of the firm.
Exactly. The return was in the willingness to tear down the old factory floor and rebuild it. That is the hurdle legacy corporations are facing right now with AI.
Tearing out the corporate equivalent of belts and shafts.
Oh yeah, middle management layers, legacy software silos, entrenched departmental routines. It's incredibly painful for a big company to do.
Which begs the question, what happens if you don't have any legacy belts and shafts to tear out? What if you are building a company entirely from scratch today?
Well, the data we have on early stage entrepreneurship suggests the entire concept of what a company looks like is fracturing.
Here's where it gets really interesting, because the researchers looked at Y Combinator startup batches, right?
They did. Over a 4-year period, from winter 2020 through fall 2024. By cross-referencing those companies with Revelio employment data, a really stark contrast emerged between non-AI startups and AI-native startups.
The AI startups start smaller, they run smaller, and they have little to no corporate hierarchy.
Almost none. The distribution of headcount is heavily skewed toward keeping the team as lean as physically possible.
So why is that a big deal?
Historically, revenue growth and headcount growth were just tethered together.
Right.
If you wanted to double your client base, you had to double your sales team, your support staff, your HR department.
Right, more output meant more bodies.
AI fundamentally breaks that correlation. Founders can automate the peripheral functions of the business, turning human capital from an operational necessity into a highly deliberate choice.
And this trend reaches its absolute logical extreme with the rise of the mega solopreneur.
Oh, this data is staggering.
It is. We have data from Stripe Economics that honestly made me rethink everything I know about traditional career trajectories. We are talking about businesses consisting of exactly one person.
The inflection point is remarkable here. Starting around 2023, the data shows a really sharp acceleration. Between 2023 and 2025, the number of single-person businesses on the Stripe platform earning over $1 million annually more than doubled.
$1 million is impressive, but it's the higher brackets that completely blew my mind.
Right.
In that same 2-year window, the number of solopreneurs crossing the $5 million and $10 million thresholds nearly tripled.
Tripled. Just incredible.
The share of individuals hitting these astronomical high income numbers has doubled in 2 years, proving this isn't just, low-quality experimentation. This is highly successful, lean firm formation.
If we connect this to the bigger picture, AI is fundamentally altering the definition of a company. It forces us to redefine what a single human being is capable of producing in a digital environment.
If one single person armed with the right AI tools can generate $10 million a year without hiring a single employee, does climbing the traditional corporate ladder even make sense anymore?
It's a question a lot of people are starting to ask.
I have to play devil's advocate here, though. Are these actually sustainable, enduring businesses? Or are we just looking at a temporary gold rush of people selling, PDF guides on how to write AI prompts? Is a $10 million solopreneur really a scalable model?
It's a valid skepticism, for sure. But the underlying mechanics suggest it is highly sustainable. Think about the daily operations of a modern, high-revenue solopreneur.
Okay.
5 years ago, running a complex e-commerce or SaaS business required a team. You needed someone coding the back end, someone writing marketing copy, someone handling Tier 1 customer service tickets, someone managing the ad spend.
You essentially had to be a manager of people before you could scale the product.
Precisely. Today, that same individual acts vastly more like a conductor of an orchestra.
Oh, I like that.
They use autonomous agents to write and test code, Generative tools create the marketing assets. AI handles 90% of inbound customer inquiries flawlessly, and algorithmic platforms optimize the ad spend in real time.
So they do more with less.
Exactly. The solopreneur is entirely focused on strategy and product market fit, while the AI executes the labor. They aren't selling prompt guides. They are running fully operational software or digital media empires.
It completely flips the traditional status symbol of the business world on its head. For decades, success was defined by how many people reported to you.
Right, corner office.
You climbed the ladder to become a director, then a VP, accumulating headcount along the way. Now, the ultimate flex might be generating 8 figures in annual revenue with a headcount of exactly 1.
It is hyper-productivity realized.
Yeah.
But there's a crucial caveat here. We have been discussing the digital space, the world of bits.
Right.
When we try to force technology to optimize the physical world, the world of atoms, the results can be surprisingly counterproductive. Does adopting tech always mean better productivity metrics in the physical world?
This brings us to my absolute favorite part of the research, the grocery store paradox.
It's such a great example.
It is the perfect case study because it is an industry every single listener interacts with constantly. To understand the paradox, we first have to agree on how productivity is actually measured.
In economic terms, productivity is a very straightforward formula. It is the total output of goods or services divided by the total labor hours required to produce them. You want maximum output for minimum human hours.
Right. And if you track the broader retail sector, so stores selling electronics, clothing, general merchandise, their productivity has steadily skyrocketed since 1990s.
Straight up.
But over that exact same timeline, grocery store productivity declined, eventually flatlined, and recently took another steep dive. Grocery completely missed the technological productivity boom.
What makes this a true paradox is that both general retail and the grocery sector were handed the exact same transformative technology at the exact same time.
The electric barcode scanner.
Exactly. In the 70s through the 90s, the scanner completely revolutionized inventory. It gave stores real-time granular data on exactly what customers were pulling off the shelves.
But the two sectors used that identical data to do two completely different things, which sent their productivity metrics in opposite directions.
Right. General retailers looked at the scanner data and used it to vastly expand their offerings of off-the-shelf, prepackaged goods.
Makes sense.
A box of electronics or a packaged shirt requires very little human labor to stock, monitor, and sell. So their output, the sheer volume of goods sold, went through the roof, while their required labor hours stayed relatively flat. The formula worked. Productivity soared.
But grocers looked at the efficiency of the scanner and decided to go the specialty route. They thought, great, the scanner is handling the center aisle so efficiently, let's use our resources to add in-house bakeries. Let's build massive, complex deli counters. Let's add a florist.
And herein lies the physical limitation of the technology. A scanner can instantly ring up a prepackaged box of cereal. A scanner cannot arrange a bouquet of tulips. It cannot custom slice half a pound of turkey breast.
The scanner gave them the illusion of efficiency, but the actual goods they were selling required highly specialized human labor.
Yes. As the share of specialty services grew within the grocery store, the demand for specialty labor grew in tandem. They were offering vastly more goods, but their labor hours were ballooning. So their official productivity metric output divided by hours lagged severely behind general retail.
But the grocers eventually realized this, right? Because around the year 2000, they figured out a rather brilliant accounting trick to kind of hide their labor inefficiencies.
They executed a massive structural hack. First, they started dedicating more floor space to high-margin, non-food items like pharmacy goods, basic merchandise, which grew fivefold.
Stuff that's easy to scan.
Exactly. But more importantly, they fundamentally changed their relationship with vendors.
This is the part that is so clever. If a major soda company or snack brand wanted premium shelf space at the end of an aisle, the grocery store agreed, but on one condition. The vendor had to send their own employees into the store to physically stock the shelves.
They shifted the labor burden entirely off their own books.
Brilliant.
The physical labor of moving the atoms was still happening, but the grocery store was no longer paying for those labor hours. Their output remained high, their official labor hours plummeted, and for a brief window, grocery productivity experienced a renaissance. The share of income going to labor steadily fell.
But that hack couldn't last forever, especially when the pandemic hit and introduced the latest wave of technological innovation, post-pandemic e-commerce and delivery. You would think an app that lets you order groceries from your couch would be the peak of efficiency.
For general retail, e-commerce was exactly that. They could close physical storefronts, eliminate display windows and cashiers, and ship millions of items from a highly optimized, centralized warehouse. It made them leaner than ever.
But for a local grocery store, e-delivery and curbside pickup actually act as a productivity anchor. Think about the traditional grocery model. For decades, the most labor-intensive part of the process, walking the aisles, locating the item, putting it in a cart, and bringing it to the front, was done entirely for free by the customer.
We outsourced the physical labor to the consumer.
Right. So what does this all mean? When you tap an app to order curbside pickup, that labor doesn't just disappear. It cannot be automated away by an algorithm.
No, it can't.
The grocery store now has to pay an employee to physically walk down aisle 4, inspect the produce, and bag your items.
The exact same scanner and e-commerce technologies were applied to two adjacent sectors, retail and grocery, resulting in entirely divergent productivity stories.
It's wild to think about. We have self-driving cars and AI writing cloud, but when I order a box of cereal online, the cutting-edge tech is literally just paying another human being to walk down an aisle for me.
The labor has simply been re-internalized. Because of this, post-pandemic grocery productivity has swooned once again, and the labor share of grocery income is rising. It proves that technology's impact is entirely dependent on the physical nature of the good being sold.
That is a brilliant way to frame it. Let's pull all these threads together because the picture we've painted today is incredibly cohesive once you see the patterns.
It really is.
We started by watching the market violently rotate from bits to atoms as we scramble to build a physical robotic body for our new AI brain. We uncovered the mapping problem, realizing that slapping AI onto an antiquated corporate workflow is just like dropping a steam engine onto a digital factory floor.
A recipe for failure.
Exactly. Then we looked at the staggering data behind lean AI-native startups and the rise of the $10 million solopreneur. And finally, we saw how the physical reality of a grocery store completely neutralizes the digital efficiencies of e-commerce.
The through line connecting all of this data is a warning about how we implement change. For you listening right now, knowledge is only valuable when it's applied.
Absolutely.
Whether you are running a giant corporation, prepping for a strategy meeting, or just building a solo project from your living room, the lesson is clear. Don't just adopt a new tool to do the same old task faster. Completely rethink what the task should be from the ground up.
Rethink the task. Don't just speed up the belt. And as we wrap up, I want to leave you with a final mind-bending question to chew on, something that bridges everything we've discussed today.
Let's hear it.
If AI allows a single person to comfortably do the work of 100, and physical robotics takes over the manual labor in the world of atoms, what happens to the global economy when the first trillion-dollar company goes public? And it only has one single employee. Keep digging, and we'll see you on the next deep dive.